We are going to study indices now. And you know, indices start from our primary school classes. We're told to write numbers based on the product of their prime numbers. And you finally leave your answer in the index form. So the word indices is a plural of index. So there are laws guiding our indices, and that's what we are going to be considering today, the laws of indices. What are the laws guiding indices? The laws of indices, and that's on law 1. A raised power x times a raised power y equals to a raised power x plus power y, not a raised power x plus y, like many students used to call it, is a raised power x plus power y, because the two of them are in the index form. Some people call it the additive law. Law 2, a raised power x divided by a raised power y equals to a raised power x minus power y. Subtractive law, a raised power x minus power y, power. And law 3, a raised power 0 equals to 1. A raised power 0 equals to 1. Anything raised power 0 is equal to 1. And that's gotten when you have the index of the number you are dividing to be equal. Take, for example, a raised power x divided by a raised power x will give us, when you subtract the power, to give us a raised power 0, and eventually our answer will be 1. Law 4, a raised power minus x equals to 1 over a raised power x. That's its reciprocal, 1 over a raised power x. That could also happen when the number you are dividing is less, the index is less than the one you are dividing, is greater than the one you are dividing with, and that will give us a raised power x, let's say it's 2, and then you have 3 as the index of the second one you are using to divide. You come up with a negative index, and that's why the law 4 says a raised power minus x equals to 1 over a raised power x. Law 5, a raised to power x bracket power y, not a raised power xy, a raised power x bracket power y, because the two of them are in the index form, and that will give us a raised power xy. Law 6, a raised power 1 over x will now be what? A root x. A raised power 1 over x will give us a root x. Law 7, a raised power x divided by power y. I'll take that again. Law 7, a raised power x divided by power y will then give us a root y bracket power x. A root y bracket power x, or a raised to power x root y. A raised power x root y. These are the 7 laws that guide our indices. We are going to take some examples now to drive home even these laws. Example, simplify, leaving the answer in the index form as possible. Now, question number 1, A. 2 raised power 2 times 2 raised power 4. That's the first law. And that means that's addition of the index. Addition of the power. That's 2 raised to power 2 plus power 4. And that will give us 2 raised power x. Because this is a number, 2 raised to power 2 means 2 times 2 times 2 times 2 in 6 places. 2 times 2 times 2 in 6 places. So that's 2 times 2 times 2 times 2 times 2. And that's 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64. B, a raised to power 8 divided by a raised to power 4. That's the second law. A raised to power 8 minus power 4. And that 8 minus 4 gives us 4. That's a raised to power 4. Number 3, 7 raised to power 8 times 7 raised to power minus 8. We can still use the first law, which is the addition of their index, and that will give us 7 raised to power 8 plus, that's why the first law, plus minus power 8. Plus and minus, we change to minus, that's why we have 7 raised to power 8 minus power 8. 7 raised to power 8 minus power 8. 8 minus 8 will give us 0. then obeying the fifth law. Anything raised by 0 is equal to 1. Anything by 0 will give us 1. Number D, 8a raised by 3 divided by 2a raised by 2. We bring the numbers first. 8 divided by 2. A now, since they are the same number, then you can then do the subtraction of their index. A raised by 3 minus power 2. So 2 will divide 2, 1. 2 will divide 8, 4. So a raised power 3 minus power 2 will give us a, or raised power 1, which is a. So 4 times a will give us 4a. Number E, x raised power x minus power 1 plus x raised power 1 minus power x. Then you still use the first law. So you have it as x 5 raised power x minus power 1 plus, from the law, into bracket 1 power 1 minus power x. When you open bracket, because this is a positive sign, the number will repeat itself. So you collect the like time, that will give us x minus 1 plus 1. X minus x is 0, minus 1 plus 1 is 0. So that's 5 raised power 0. And the third law, that's 1. For anything raised power 0 equals to give us 1. Number F, 2 raised power minus 4. That's law 4. 2 raised power minus 4. We have to get the reciprocal, and that's 1 over 2 raised power 4. And 2 raised power 4 is 2 times 2 times 2 times 2. That is in 4 places. 2 times 2, 4 times 2, 8 times 2, 16. That's all you have. That's 1 over 16. Number G, b raised power 3 plus b times b raised power 4 times b raised power 5. The first law, you add their index, and that's why you have it as b raised power 3 plus power 4 plus power 5. And the denominator, b raised power 6 times b. And that's why you have b raised power 6 plus power 1, because b now means power 1. So when you do the addition, 4 plus 3, 7, plus 5, 12. And that's why you have b raised power 12, and 6 plus 1, 7, divided by b raised power 7. So the second law, you subtract their index. So b raised power 12 minus power 7. And 12 minus 7 will give us 5. That's why we have it as b raised power 5. H, 5 into bracket a raised power 4 bracket power 3. 5 into bracket a raised power 4 bracket close power 3. That tells us that the power is only affecting a raised power 4 and not 5. And that's why we just multiply the power of a, the index of a, and the one in the bracket. That's the fifth law. 5 into a times a raised power 4 times 3. And 4 times 2 will give us 12. So we have that 5 a raised power 12. But on the other side, this question I now says 5 into bracket open 5a raised power 4 bracket power 3, meaning the power, the index here is affecting 5 and a raised power 4 separately. So you have it as 5 raised power 3 times a raised power 4 times power 3. And that will give us a raised power 4 times power 3, which is 4 times 3, 12. Then 5 raised power 3. 5 raised power 3 is 5 times 5 times 5. So 5 times 5, 25. 25 times 5, 125. 3 raised power 12. Next one is also the index form, but now a fraction of index 16 raised power half. 16 raised power half. It will change to the index form, and that's 16 root 2, which is square root. So that's why the 2 is not indicated. And what does that mean? The mathematics there is you write this as the product of its prime. That will give us 4 times 4, which is 4 square. So the square and the square root will cancel out, and our answer will be 4. Okay. 64a raised power 6 bracket power 1 over 3. And that will be what? The cube root of 64a raised power 6, the cube root. So you can then split that 64, which is a raised to 4. 64, which is 4 raised power 3, times a raised to power 6. So when you do that, cube and cube root, and this will cancel. Half, you just write 1 over 3 times 1 over 3 to give us a raised to power 2. So 4 times a raised to power 2 will be 4a squared. The next one now is 0.027 raised to power 2 over power 3 divided by power 3. 0.027 raised to power 2 divided by power 3. Now this is a fraction. We call it decimal fraction. Decimal fraction. Decimal fraction. So we change it to normal fraction. And that's now after the decimal point, you have the tenths, the hundred, and the thousand. And that's why we are dividing by 1,000. That's why you have that 27 divided by 1,000 raised to power 2 over 3. So, and that will change it to the cube root of 27 over 1,000 bracket power 2. That's the seventh law. So what's the cube root? 27 will be 3 times 3, that's 3 cube. 1,000 is 10 times 10 times 10, that's 10 raised to power 3, 10 cube. So then you can now factorize the cube. So the cube and the cube root you cancel out. So you have 3 over 10 bracket power 2. And 3 over 10 bracket power 2 means 3 over 10 times 3 over 10. 3 times 3 denominator 9. 10 times 10 numerator first. 3 times 3 numerator 9. 10 times 10 denominator 100. And since you started with a decimal fraction, your answer must also be in decimal fraction. That's 900. We taught that from our primary school class. M. Question M. We are simplifying. 36 over 25 raised to power bracket minus half. 1. Negative to cancel, it will change to reciprocal. And that's why we have reciprocal as 1 over 36 over 25 raised to power half. Now, when you have that, it will change to, when you do that, you have reciprocal. The numerator will change to denominator. Denominator will change to numerator. That's why this is changed to 25 over 36 raised to power half. So that will be the square root of 25 over 26. So square root of 25 is 5 squared, 36, 6 squared when you factorize. So square and square root to cancel, and your answer is 5 over 6. Can you see that we are leaving it in the real fraction because the question was originally given to us in fraction. We didn't change it to decimal fraction like the previous one we solved. Now we move to another topic of which is called exponential equation. Exponential has to do with index, it has to do with power. So the first question says solve the following equation for x. Solve the following equation for x, and that's a x raised to power half equals to 3. From that sixth law, that will be what x square root of x equals to 3. So to remove the square root sign, you find the square of both sides. So that's why we have x square bracket power 2 equals to 3 square, both sides. So the square and the square root cancel out, and 3 square is 3 times 3, 9. Again, B question from exponential equation. 4y cubed equals to 256. 4y cubed equals to 256. That's the coefficient of y cubed is 4. So you divide through both sides by 4. And that's why we divided by 4. 4 will cancel 4. You have y cubed. 4 will divide this. You have 64. 256 divided by 4. We have 4 here. 6. 24 remainder 1 in 16, 4. So now you have this. Y cubed equals to 64. So we can find the cube root of both sides, and the cube root of this will give you cube and cube root to cancel. Cube root of 64 is what? 4 raised to power 3. Then the cube and the cube will cancel. Your y will be equal to 4. C. 8 raised to power x equals to 32. Before you can equate that the powers are equal, the numbers or the base, the numbers must be equal. So we have to convert 28 to 2 raised to power 3. That's 2 times 2 times 2. And 35 to 2 raised to power 5. That's 2 times 2 times 2 times 2 times 2. Then from that law, the 5, when they have power, you multiply the power. So 2 raised to power 3 bracket power x equals to 2 raised to power 5. So 2 raised to power 3 bracket power x, when you open the bracket, the powers to multiply, you have that 2 raised to power x equals to power 5. So since the numbers are equal, the index are equal. 3x equals to 5. So x is what? 5 over 3. And that's an improper fraction. That's why we have one number 2 over 3. T, 5 raised to power x minus power 1 equals to 125. Since you have to make the numbers equal for the index to be equal. So 25, when you write it in the product of its prime, 5 divide this, 25, 5 divide 25, 5 divide 5, 5. So 125 is written as 5 raised to power 3. So since the numbers are equal, the powers are equal. X minus 1 equals to 3. So moving 1 to the other side to be added, change to addition, x now becomes 3 plus 1, x equals to 4. So we have this as our classwork, which I want you to solve, and you are going to submit that format. Simplify the following. A, x raised to power 7 times x raised to power 1. B, 6 x raised to power 6 divided by x raised to power 3. C, 27 over 8 bracket close raised to power minus 1 over 3. D, 0.49 raised to power half. Question number 2, solve the following for x. So 3x raised to power minus 3 equals to 81. B, 8 times 2 raised to power x equals to 32. These are the questions that you are expected even to solve. Now, see you again in the next class. I am Alawa DME. Thank you. Subscribe to my YouTube channel.